Newton's laws of motion.
Newton's second law of motion.
What is Newton's second law?
Second law is defined as the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object.
The equation for this is that the acceleration is proportional to the net force over the mass, or the net force equals the mass times the acceleration.
What are the components to this equation?
I don't know, man.
What is it? What?
Acceleration. Vroom, vroom.
In physics, acceleration is defined as the rate at which an object changes its velocity.
So when there's no change in velocity, or the velocity is constant, the acceleration will equal 0.
The units for acceleration is meters per second squared.
Force.
A force is a push or pull on an object, and it's also measured in newtons.
Mass.
Mass is how much matter there is in something, and is generally measured in kilograms.
How can we apply this concept?
I don't care.
I don't care. But you should care, and I'm gonna tell you anyways. Let's say you have a 10 kilogram block, and it's moving at an acceleration of 5 meters per second squared. What is the force of this object? We can use Newton's second law to solve this problem. If the acceleration is proportional to the net force over mass, that means that the net force is proportional or equal to the mass times the acceleration. And since the acceleration is 5 meters per second squared, and the mass is 10 kilograms, you multiply 5 times 10 to get you a total of 15 newtons as our force.
Well, there's Newton's first law. Newton's first law of motion is often stated as an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force.
Formally stated, Newton's third law is, for every action, there is an equal and opposite reaction. The statement means that in every interaction, there is a pair of forces acting on two interacting objects. The size of the forces on the first object equals the size of the forces on the second object. Abby, tell the joke. Tell the joke.
Oh, wait. Oh, no, these are inappropriate. I'm on BuzzFeed. Let's get out of here.
Seriously doing a video.
Day 400. We're still trapped in Sam's house. I think we ran out of food and water. SOS.
Might resort to
You guys go, yeah. So literally just go like,
Kailyn. You should go like,
yeah, and just fall
like
back.
this.
Yeah. Okay, go, do it. Yeah, that's... Abby, do you have the joke yet?
No, I don't! You know, your phone will probably load faster.
Abby, you are a joke. Abby, since you don't have a joke, I'm gonna tell you a joke. Okay, ready?
Okay.
Okay. Who's on the case when electricity goes out?
Who?
Sherlock Holmes.
Are you recording? May the mass times acceleration be with you.
Beautiful.